Hi everyone, welcome to Last Minute Maths, and in this video we're going to go through the November 2021 Edexcel Paper 1 higher tier and non-calc. Right, without further ado, except for one small thing, just a hello to my viewers in Greece. Thank you for all your support and kalimera. Right, now to jump straight into the paper itself, I'm going to try and get the video down to as short a time as possible. Question 1, nothing much to it, straightforward, long multiplication. Just want to point out the decimal places are what you need. For any of you who sometimes make a careless error on this, remember to count out 3 decimal places because there's 3 here, there, altogether it's 3 in between the two numbers. Nothing more needs to be said, all right? Division, next one, part B, okay? The bus shelter, bus stop as some people call it, okay? Remember that the divisor, right, the number you're dividing by, that has a decimal place in it. So what you have to do is to turn that into a whole number. In order to do that, you're moving the decimal place once. And you must do the same to the number being divided, all right? That must also go across 598.4. So as long as you remember to do that, the rest of the division rules are exactly as you would expect. No surprises there. All right, number 2. Okay, so Venn diagram question. And it's all about listing out the numbers and making sure you're counting everything and not missing something out. So your universal set, which is that, okay, that thing there, has even numbers less than 19. In the real exam, right, make sure you're writing them out as I've done there, all right? So 2, 4, 6, 8, 10, 12, 14, 16, and 18, okay? Fine. Then start putting the numbers into their appropriate groups. So A has 6, 12, and 18. And B, you've got your 2 and the 6 and the 18 already there. So the ones that aren't represented in A are only going to be the 2 and the 14. Don't repeat the numbers. In other words, do not put the 6 and the 18 in again. Okay, just once. And anything left over, which is not in A, not in B, these are the ones that I've highlighted here. All right. There you go. 4, 8, 10, and 16 go in the universal set. All right, the leftover numbers. Again, not too difficult. All right. Moving on, number 3. Okay. You've got fractions as mixed numbers. All right. The first thing you need to do is change to improper fractions. Okay, that's first step. That then allows you to apply your normal fraction operations to the numbers without having to worry about the integers. All right, so in case you're not sure, how do we convert 4 and 1/5? Just to give you just a little revision of that, sorry. Multiply the denominator by the integer, all right? So 5 times 4 plus the 1 that we have on top already, plus 1, and then everything stays over the original denominator of 5, all right? So that's how you convert a mixed number to an improper, and that is 20 plus 1 over 5 equals 21 over 5, all right? You know what? Just before I confuse anybody, I'm going to get rid of that. Let me do that again. There we go. All right. That's where the 21 over 5 came from. Right, moving on. How do we actually do the subtraction here? Okay. As always, you want to get the denominators to a common denominator. In this case, it's simple. It's 5 and 3. Just use 15. So I need to multiply the 5 by 3. Whatever I do to the denominator, I must do to the numerator, i.e. the number on top. So multiply that by 3 as well. That's where we get the 63 over 15. On the other side, you're multiplying the 8 over 3, top and bottom, by 5, right? That gets us the 40 over 15. So now we have the same common denominator, 15. Then it's a straightforward subtraction, 63 minus 40 over 15, which is 23 over 15. And then remember, the question says, give your answer as a mixed number. Don't lose track of the question, right? It's so easy to lose a couple of marks for no reason whatsoever. Pay attention to the question and give the answer in the right format. So 15 into 23 goes once, and 8 remainder, so 8 over 15, and the answer is 1 and 8/15, all right? So ensure the format is correct, all right? Right, number 4. Now, this one takes a little bit more talking. Simple question. They give you the value of a couple of people's houses at the end of a particular year, all right? And you've got one of them is 220, the other is 160. Then they say that after a couple of years, which the years themselves are actually irrelevant, all right? The actual important bit of data is that one of them decreased by 20%, the other increased by 30%. Okay, then they want you to compare the two values and see which one has the greater value. All right, so that's the crux of the question. All right, starting with Tamara's house, T. We know 10% of 220,000 is 22,000. You divide that by 10, okay? And that gives you 22,000. Remember, it's non-calc, so don't reach for your calculators. Start getting used to the mental maths. So if 10% is 22,000, then 20% is going to be simply double that, which is 44,000. And it's a decrease, so we're taking 44,000 away from 220,000. All right, so again, a little bit of either mental maths or just work it out on the side if you really need to. And the answer is 176. All right, so you have it there. Same sort of process with the other one, right? Rahim's house. So that's 10% of 160,000. Again, you're just dividing by 10, so 16,000. Fine. And it says there's a 30% increase. So this time we're going to add on 3 lots of that, because that was 10%, you want 30%. 3 times 16 is 48, so 48,000, all right? So 160,000 was the original, plus 48,000 equals 208,000, all right? So therefore, because obviously 208,000 is greater than 176, your answer is simply the sentence here, Rahim's house had greater value at the end of that. That's all you need to write. No more fuss than that. All right, number 5. We have Rosie, Matilda, and Ibrahim. Right, they collect stickers. And then the ratio of stickers is given 4 to 7 to 15. All right. Then they add a little bit of extra information that Ibrahim has 24 more than Matilda. All right, so we're relating plus 24 going from there to there. All right, so whatever Matilda has, you add 24 to it to get Ibrahim's number. All right. So first of all, always start with an unknown, right? Use X or whatever you want to call it. Because of the ratios, we're going to say that Rosie has 4x and Matilda has 7x, Ibrahim has 15x. So that is according to the ratios, all right? Then we have that extra bit of information. You have to relate Ibrahim's number to Matilda's number. And that's that equation there, all right? This is Matilda's. Add your 24 and you get Ibrahim's, all right? So solve that. Straightforward. So 15x minus 7x, 8x equals 24. X equals 24 over 8 equals 3. All right. So nice and simple. We now can work out the number of stickers that each person has. So Rosie has your 3, right, times 7. My apologies, sorry. Let me say that again. Rosie has 3 times 4, so that's 12. Okay. And Ibrahim has 15 times. Oh, I think I made a mistake there. Apologies, guys. Yep. I knew there was something wrong with that. Didn't look right. There we go. Even teachers can be fallible. Let me correct that then. 3 times 15. All right. So 45. And therefore, the actual answer is 45 minus 12. And that is going to be 33. Okay. Sorry about that. Big. There we go. All right. Hopefully, I haven't confused you too much. Any problems or questions on that, please leave it in the comments. Okay. Okay, right. Next question. The prism, right? Whenever you're working out volumes, areas, etc., all right, you've got to watch out for the end shape. That's the most important part. All right. So the cross section is what I'm talking about there. This one is a right angle triangle. All right. The base of the triangle they've given us is 5. And then they're giving us a couple bits more information. So the length is that 25. And they've given us the volume. Total volume is 750. All right. So the height of the prism is what they're after. Okay. So we're going to have to start with the volume and work our way backwards. All right. Just to remind you of the formula, the volume of a prism is the area of the cross section times the length of the prism, right? So that's the end face that I was talking about. Right, so now we put the numbers in. The volume we know is 750, and that equals the area times the length, which is 25. Okay, rearrange that, and we can see that area equals 750 over 25. All right, so that's 30. Okay, so the area of the triangle at the end, the right angle triangle, is 30 square centimeters. So again, the area is given by half times base times height. And we're going to rearrange that a little. We know it's 30. So area equals 30. Half times the base times the height, 30. Rearrange that again. Okay. And you get the height is 12. All right. And units are given here anyway, so you don't need to worry about that. All right. Then we have question number 7. Looks a little imposing to begin with, but it's actually not very difficult. Right, so the surface area of the cube, okay, that's read carefully. Surface area of the cube is equal to the surface area of the sphere. All right. So it's a show that question. All right. First of all, the surface area of the cube is x squared. Each one of those is x squared. Okay, because it's x times x. All right. And that cube is going to have 6 faces. So all you've got there is 6x squared. all right? Then the surface area of the sphere, all right, with radius 3. Okay, make sure you note the radius there. Not the diameter, all right, the radius. Very common mistake. All right, so the surface area of a sphere, which they've given you, so nothing to look up there. That's going to be 4 times pi times r squared, all right, and 9 times 4, 36 pi. Okay, so that's fine there. The two quantities equal each other, all right, like that. So just write it out. 6x squared equals 36 pi, all right. Cancel out a 6 on both sides, divide by 6 on both sides, and you get x squared equals 6 pi. And the way to get rid of the square is to square root both sides, all right? And you end up with x equals square root of 6 pi, all right? It may look strange, but that is right, okay? In this particular paper, as you'll see later on, there are some strange looking numbers. Don't be put off by it. The most recent GCSE papers have lots of non-integer and very weird rational numbers. So like I said, don't be put off. If you know what the method is, what you're doing, be confident in your answer. All right? Not like me making a mistake in the previous question there, the one before that. All right, let's move on. Number 8. Straightforward quadratic. What we want to do is to get the thing equaling 0. So you move everything onto one side. All right, so you move that and you move that. And you end up with x squared minus 5x minus 24 equals 0. So that gives us your standard quadratic equation. And, right, then it's a question of factorizing. What you want, right, in order to factorize it into those two brackets is two numbers which multiply to 24 and add to minus 5, right? That sign is very important, okay? So in plain English, in many ways, it's like factors of minus 24. I'm going to put the minus in, okay? Minus 24 and minus 5, all right? And what you have is a choice of minus 8, 3, or you could initially think that it might have been 8 and minus 3. Both of those combinations will multiply to minus 24. But when you add them, like that, this one gives you minus 5, that one gives you plus 5. So it's not that one, all right? This is the combination you want. You must use the signs in both numbers to make sure you get the right combination. All right, so we get x minus 8 times x plus 3. And with the usual thing, when two numbers multiplied equals 0, then one of them at least must be 0. So if x minus 8 equals 0, then x must be 8. And if x plus 3 equals 0, then x must be minus 3. All right? So a little bit of quadratic revision there. Your answers are minus 3, comma 8, two values of x. Okay, number 9 is all about the index laws. Okay, and I'll put down the basics that you need here. Any number to the power 0 is always 1. Doesn't matter what the number was to start with. All right, therefore, the answer is just simply 1. Part B, okay, remember again the rule where you're multiplying x to the power a times x to the power b, and what you do, you get x to the power a plus b. So when you're multiplying the actual numbers, the powers are added. All right. So in this case, you've got 3, which is the same as 3 to the power 1, times 3 to the power 6, and 3 to the power minus 6. You just add all the powers. All right. So 1 plus 6 minus 6 is just 3 to the power 1, which is 3. All right, nice and simple. Don't be tricked into making up all sorts of big numbers and things. Right, part C. Find the value of 2 to the power minus 4. Now this one takes a little bit more thinking about. Okay. First of all, the negative power. That equals 1 over something. Right? In other words, you are flipping it upside down. For those of you who are a little pedantic, it's called the reciprocal. The reciprocal of a number is where your number is flipped upside down. Okay, so reciprocal of 2 is a half, right, as you can see there, and that is then taken to the power 4, all right, which is the same as, for example, you could write it as 1 to the power 4 over 2 to the power 4. 1 to the power 4 we know is 1. 2 to the power 4, as I've said here, is 16. All right, so the answer 1/16. Okay, and the final one. For those of you who've forgotten what a fractional power is, just to illustrate, x to the power 1 over y. All right, fractional power means it's a root. Okay, not just a straightforward square root, but it's like the y-th root of x, if you like, yeah, for want of a better expression. So 27 to the power 1/3 is the cube root. It's called the cube root of 27, all right? And that is 3. Why? Because 3 times 3 times 3 equals 27. That's what it means by the cube root. What number times itself 3 times will give you 27? And that's 3. All right? Okay. Right. Next one. Number 10. Diagram shows a shape made from 6 identical squares. Yeah, so make sure you note that. That means that the length of the sides of each square, obviously it's a square, so they must be the same. Give it some sort of a label. All right, that really helps to sort out what you need to do. So given that we're going to call it A, that's what I've chosen, and they're saying that the total area of the shape, 1, 2, 3, 4, 5, 6, 6 of those squares, so the area is 6a squared, equals 5406 centimeters, 5,406 centimeters. All right. So a little bit of rearrangement. A squared equals 5406 over 6. Now I want to show you just a simple method of division when you've got it like that in a fraction. 6 into 5 doesn't go. 6 into 54, 9, right? No remainder. So the 0 stays where it is. The 6 into 6 is just 1, all right? So a simple way of doing a division without having to rewrite everything. And you get your answer as 901. A squared is 901. And it says, give your answer correct to the nearest whole number. A, therefore, is the square root, right, of 901. And this sign here it means approximately. Right? Wavy equal sign is approximately 30. Okay. Next part of the question says, is your answer to part A an underestimate or overestimate? In other words, is it too small or too big? Okay, in value. And give a reason for your answer. Make sure you answer that part of the question. It is an underestimate. All right. Why? because 30 squared is actually 900, and 900 is less than what it actually is, which is 901. So it's just a teeny bit smaller than the real answer. So it is an underestimate. Right, number 11. Two rectangles, A and B, slightly different shapes, okay? And they're saying the area, okay, of each of them is equal, all right? So area of A and the area of B. And they want an expression, now watch out, for Y in terms of W, right? Make sure you get into the habit of, if necessary, underlining or circling the key parts of the question. Otherwise, you might, in the heat of the moment, in the pressure of an exam, you might end up doing it the wrong way around. Okay, so double check. All right, how do we go about this? Well, what you have, the area of a rectangle, as you know, length times height. Doesn't really matter which order. So here I've got 6 times 2w plus y. Make sure you're using brackets, all right? So 6 times the whole of 2w plus y. And on this side, we've got 7w times 3y plus 6. Again, make sure you're using the brackets. Right, expand the brackets out. 6 times 2w, 12, 12w. 6 times y, 6y. On the right-hand side, you've got 7w times 3y. Be careful with this. Don't forget either of the letters. Later on, it becomes important. 21wy, all right? And then 7w times 6, 42w, all right? Start bringing everything together where we can. Now, because we want y, yeah? Y becomes the subject. So if you're revising this from your books or your notes, it's one of those examples where you're rearranging a formula or you're changing the subject of a formula, right? Of the formula. All right. So because we want y on its own, I'm going to bring all the y's to one side. All right, all the y terms to one side. So I'm picking the left-hand side here. And I'm going to move all the w's and anything else that doesn't have a y to the right-hand side. Now look what we have. 42 minus the 12. All right, oops. Let me redo that. 12w, and that gives you 30w. Sorry, I think my pen is playing up a little, so be patient with me if I write things wrong and then do whatever, trying to erase it. Right, 30w, so you can see where that next step came from. And now we factorize the y out of the two terms on the left-hand side, okay? So that's the same as y brackets 6 minus 21w. Don't lose the w. That has to stay there. All right. And now what do you have? Y times something equals 30w. The whole of the something, right, all of it in the brackets, is now going to go the other side and divide as. So you get 30w divided by 6 minus 21w. Okay. Now notice that the 30 is a factor of 3, top and bottom. So you can divide everything by 3, the 3 terms. 30 divided by 3, 10, 6 divided by 3, 2, and 21 divided by 3, 7, etc. That is your final answer, okay? If you leave it with that factor of 3 still in there, you will lose a mark, all right, because it's not in its simplest form. Okay, moving on. Now, this is not as complicated as it looks. There's only one important point to say here. when you're doing a cumulative frequency graph, all right, you must always put the point on a graph at the end of each interval. So these are your intervals, and the 4 effectively relates to the end of the interval. So in each case, we're plotting that value at the bottom, right? Because what a cumulative frequency is saying, that the height, right, up to 5 centimeters, right, there's 4 of them. Okay, so up to 5 centimeters, the frequency is 4. We don't know where the frequency is in those 5 centimeters, so we have to go with the end value, right, in each case. I hope that's explained. Any confusion, leave a comment and I'll reply to that. Right, so we are, now let me see if I can get this on the same graph just about. Okay, so you can see we've taken 5 and 4. All right, same again, 10, and the value for 10 is 11. So just about there, 11. The value for 15 is 24. Okay, there. And then 20 is 34, right? Let me just do that. And 34 for 25, 38, just about there. And for 30, it's the end one. It should really have gone there. So 40, all right? So that's how you get the cumulative plot. And then, you join the dots the best you can, okay? All the way along there, etc. Okay? Use a sharp pencil. Okay? Best thing to do in the exam. In case it goes wrong, you can rub it out and do it again. All right? Okay, so that's that bit. That's a cumulative frequency curve. And then it says use a graph to find an estimate, all right, for the median height. The median height is the middle value when put in order, is a short definition of median. So basically out of 40, we want roughly the 20th value. So what have I done? You've got 20, all right, out of your 40. Go along, and it crosses just about there. And I'm reading it off as an estimate to be 17. All right? Hopefully that makes sense. Basically, it's halfway up the curve. Right, number 13. This one is actually only 1 mark, but you still have to explain it properly. All right? So they're trying to change 0.43 recurring. So 4, 3, all of it recurring. So that actually means 0.43, 43, 43, etc. All right. Notice you would need to move the decimal place times 100 in order to get 43.4343, right? Because you want the decimals to line up exactly, all right? Now, in this case, look here, by multiplying it by 10, right, the decimals do not line up. All right, that is the mistake. And it says evaluate. All right, so just say what's going on. And as I've written there, 4.34 recurring minus 0.43 recurring does not remove the decimals and is not an integer number. All right, you could have just said the decimals don't line up. Well, that's perfectly adequate for 1 mark. Right, enough said. There's a lot of talking for 1 mark. Number 14, similar to the one that we looked at a little while ago. A shape, all its measurements are in centimeters, which is fine. The area of the shape is A, and it's a show that. So what we're going to do is chop it the way I've shown you here. This rectangle is B, and this rectangle is going to be C. So the area A of the whole shape is area B plus area C. All right, we're going to work out each of those individually. B, we can see, is x plus 1 times x plus 11. All right, so that's what we have there. And now the area for C, we need to work out slightly differently. Because the whole length of the bottom is 2x plus 6, we need to minus that the width of B, which is x plus 1, from that total. So that's what I've done here, all right? 2x plus 6 minus the whole of x plus 1, all right? Make sure you apply the negative to both bits of the terms in the brackets. So 2x minus x, and 6 minus 1, 5, all right? So the calculation for C is one part of it, the bottom part, is x plus 5. And we use a similar process for the height, because we know the total height is x plus 11, and we're coming 4 down, right, to come to the top edge of C. So that one is going to be x plus 11 minus 4, so x plus 7. All right, so that's where we get those two brackets from. Expand everything out, right? Remember, whenever you're doing brackets, right? Right, let's just do this. Okay, like that. Remember, you want A times C, A times D. Then you want B times C and B times D. So you're going to get 1, 2, 3, possibly 4 terms. All right. Don't miss any out. Make sure you're following what's going on. All right. I don't think it needs too much explanation at this stage. So we have two quadratics, and there are no minuses or anything else to worry about. So just add all of that up, and lo and behold, you've got the answer. All right. Okay, number 15. All right, what we're doing here is no different to, I think, one of the first questions earlier. It's finding a common denominator for 2x and 5, okay? We don't have any other choice because we've got an x in it, so we want it to be 10x, all right? Whatever you have to do to turn the 2x into 10x, you do the same to the 4x plus 3. So if you look at this one here, you've got the 2x times a 5, and multiply the top by 5 as well, all right? Always multiply top and bottom by the same number, and that way the fraction isn't actually changing. Looks different, but the value remains the same. All right, so if we want 10x on the bottom of the second one, then this time we're multiplying by 2x, top and bottom. All right, so multiplying all that out, you've got 20x plus 15 on the top, and then the 6x from the second fraction, all above the common denominator, 10x, all right? Simplifying all that down, you've got 26x plus 15 over 10x, all right? Nothing more to simplify there. There are no common factors or any other clever tricks. Nice and simple. Okay, number 16, all right? Probability type question, and it says 3 red counters, 5 yellow in a bag, and takes at random 3 counters from the bag. It implies no replacement. Okay, doesn't say puts it back. All right, so therefore you assume that there's no replacement, and that means the probability changes after each selection. All right. Okay. The question says, what's the probability that it takes exactly one red counter? All right. So there are different ways of doing this. You can go red, yellow, 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 red, yellow, 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 red. Okay. Must consider all options. And the proper term for it is actually combinations. Okay, so let's look at the red, yellow, yellow option first. What we have is the probability of picking a red and a yellow and a yellow. Okay, in probability, and means multiply or times. Okay, or means add. Okay, right, so the probability of getting a red is 3/8 at the beginning. Okay. Then the second pick has to be a yellow. There are still 5 yellows left, but only 7 counters in total. So we must reflect that in the second probability. In the same way, the third probability, the third counter, to be a yellow, there's only 4 yellows left if we've already picked one. And in total, there are 6 counters left. So that's where we get the 4/6 from. And because it's red and yellow, right, as I've said here, we are multiplying that. So 3/8 times 5/7 times 4/6. All right. That's one combination. Okay. The second combination is yellow, red, yellow. Okay. Like that. And we do the same process again. So first yellow must be 5/8. The probability of picking a yellow first is 5/8. The second counter being red would be, well, there's still 3 red counters in the bag, but there are a total of only 7 left. So it's 3/7. Then the third counter being yellow again, well, there were 4 yellow ones left and a total of 6. So you can see where those numbers came from now. And repeat the same thing again for yellow, yellow, red, which I think is now self-explanatory. Now look at this. If you notice, all 3 combinations, right, have the same denominators, 8, 7, and 6. Okay, that's where these come from. And indeed, the numbers on top, because they're multiplying, it's always some form of 3 times 4 times 5 arranged in different orders. So what we actually have is 3 times the same probability combination. All right. So for example, 3/8 over 5/7 over 4/6. Simplify the fractions down a little bit. And I hope I've got this right. Let's just take a look. The 3 and the 6 cancel down to a half. Yeah. And the 4 and the 8 also cancel down to a half. So you've got a half times 5/7 times half. All right. So that effectively is 5/28. And then remember the 3, and that gives you 15/28. All right. When you are saying it's one combination or another combination, all right, that's where you've got the add. So if I present it like this, hope that makes better sense now. All right. So within a combination, red and yellow, you're timesing the 3 probabilities. And then the different combinations, it can be that, or that, or that, etc. Then you're adding those probabilities. All right. Again, any questions, then please leave it in the comments and I'll be happy to explain further on that. Number 17. It's something called linear programming. Again, for the formal maths term, if you're looking up or Googling notes on this, it's linear programming. All right. Okay. With the first equation, you need to rearrange it to the y equals mx plus c format. All right. So move everything across, rearrange to get y on its own. So we have x minus 4. So let me just do that for you. 2y is less than x minus 4. And then y is less than x. And I'm going to split this up a little now, just to show you where the numbers came from. So therefore, y is less than x over 2 minus 2. All right, there we go. That's where we got that from. The next step, right, is look at the other two. Neither of those need any rearranging. Okay, they're exactly as they should be. Nice and simple. Let's do the 2y plus 4 is less than x value thing using that one there. Okay, so we know, if you remember the y equals mx plus c rule, y equals plus c, the m is a gradient and the c is the y-intercept. And in fact, in the next couple of days, I will be putting up a video on y equals mx plus c. Anybody who's a little unsure of this, please do watch out for that and perhaps take a look at that video when it comes out. Right, what we're going to do, we know that this y is less than x over 2, i.e. half x minus 2, goes through a y-intercept minus 2, all right? And we know it has a gradient of a half, okay, that one there. So that means it goes, for example, 2 across and 1 up. 2, 1, okay? That is a gradient of a half, all right? So that's where I've plotted this next number, and then that one, etc., and then drawn a straight line through it. Okay, so that gives us that particular line. Next thing, watch out, it says y is less than a particular line, whatever it is, right? Less than means below, okay, under. So that's why we want this region here, okay? Anything above it is out. We don't want that, all right? The second one is fairly simple. It's x is less than 3. So an x equals line, so this one is 3, and we just draw a vertical one through x equals 3, a vertical line, and we want x is less than 3, all right? And so it's everything less than 3 to the left of that line, all right? Everything to the right is to be removed. And finally, you've got another one, straight line equation. This time, it goes through, right, and I'm going to write that here, I suppose here. Y is less than 6 minus 3x, okay? So the y-intercept is 6, and the minus 3x gradient means you go across 1 and go down 3. All right, that gives us a minus 3x gradient. All right, so next point is there, and so on, hence the straight line. Again, we want y is less than, all right? So it's got to be whatever's under that line there, all right? So we want that region there, this region there. So effectively, and I'm going to switch color here, just to show you what's going on, the bit that we want is that bit there. Now, I must be honest, when I first saw this particular question, I thought they'd made a mistake, or indeed, am I making a mistake? Because it's unusual. Normally, they keep the area like in a triangle or a quadrilateral, something like that. But this time, they've gone a little bit different with it. So if anybody's confused about this, please, again, drop it in the comments, and maybe I'll do a line on inequalities. One important thing that you must look at, and I haven't done it on this, these should, oh, hang on, let's change the color again, please. Yep, okay. These things should be dotted lines. And that is really important, okay? Should all be dotted lines. Why? If it's greater than or less than, then it should be dotted because the values cannot be on the line. If it's greater than or equal to, less than or equal to, then it's a solid line, right? I haven't done the dotted lines, I admit, before anybody complains, simply to make it clear as to what lines we're dealing with. But if it's only less than or greater than, then it should be dotted lines. All right, so please watch out for that. I have done it solid intentionally, and it's not a mistake there. All right, move on. Number 18. Now the questions start getting a little bit trickier. Okay, you've got a trapezium, A, B, C, D, and in this particular case, right, they're giving you the area. All right, so area's fine, we can work that out, but they're giving you the additional bit of information. Length of AB to the length of CD has a ratio of 2 to 3. Remember what I said before. It's use a variable. Okay? So what I've said, if it's 2 to 3, A to B, I've made it 2x, and 3x for D to C, or C to D, whichever way. The length doesn't really bear any direction. And they want the length of AB. All right. So what we have, the formula for a trapezium, the area of a trapezium, as you can see, it's A plus B, i.e. top plus base, all divided by 2, and then multiplied by the height. And the height there. And that's got to be, this height has to be perpendicular. No, let's make it clear. The vertical height, all right? Not slopes or anything like that. It's got to be vertical, all right? In order to find the vertical height, as you can see here, all right, what I can use, notice they've given you an angle there, and they've given you a slope. Straight away, you should be thinking SOHCAHTOA trigonometry. All right? Because you can use that information to find what the height is. This is the height there. All right? So, we know in SOHCAHTOA, all right, in this particular case, you have an angle, 30, and the height here represents the opposite side to the angle, and the slope, BC, is the hypotenuse. So effectively, because we know the hypotenuse and we want the opposite, all right, we want to use the sine value. SOHCAHTOA, right? So means sine equals op over hypotenuse, all right? So h, opposite, over hypotenuse is 6, h over 6 equals sine 30. And here you must recall, and it's a non-calculator paper, all right, that sine 30 equals a half. And I am going to write something here. In the new GCSE maths papers, they expect you to know trig values for sine, cos, tan for 0, 30, 45, 60, and 90. So make sure you learn these, right? Memorize these, okay? Once I've done the question, I'll show you how that works. Okay, so rearrange that and you find h equals 3. So now put everything back into the formula that I had earlier. Remind yourself that my top AB was 2,6 and the bottom CD or DC, excuse me, was 3x, all right? So put together, you've got 5x divided by 2 times by 3, all right? So 1.5 times 5x. And what I've done is left it as a fraction because, again, it's a non-calculator paper, so you've got to work with whatever's easiest to work with. And you get 15 over 2x, so 15x over 2 equals 66. And this is the tricky bit, that bit there. Effectively, you've got 66 divided by 15 over 2. Remember the rule, when you divide by a fraction, you times by the reciprocal, turn it upside down, all right? And then you get this strange number here, 132 over 15. AB is what the question was actually asking for, 264 over 15, and it's 17 3/5 to be precise, all right? As I said earlier, this paper has some strange numbers in it, and I can't see there being any other option but to use that kind of number. So do use fractions if it's more precise, rather than try and do the decimal. They'll accept both, but fractions in this case are more precise. 5 marks, so don't be surprised at the amount of working. Right, almost there. Number 19. This actually relates to one of the other videos on my channel that I did months ago, and it's just rationalizing the denominator. So again, if you're looking up what to revise for this one, rationalize the denominator when you have surds. Denominator. Okay, all right. That's a topic you should be looking up. Whenever we are trying to rationalize a denominator, we start with a denominator that has a surd in it, in this case, root 3, all right? The rule is multiply top and bottom by the same pair of numbers, exactly the same, all right? But change the sign. Reverse sign. Okay? Opposite sign, whatever you want to call it. But it must be top and bottom. Okay? Make sure you're doing that. Okay, now, when we're multiplying top and bottom with the same thing, again, it's like I said a little while earlier in a quadratic. Make sure you're multiplying all the bits. Don't miss something out. Okay? So 8 times 5, 40. And then 8 times minus root 3, minus 8 root 3. Then you've got root 12 times 5, simply 5 root 12. And then you've got the root 12 times the minus root 3, which actually can be written as minus root 36, as I've crossed out there. And root 36, remember, is simply 6. So that is minus 6. On the bottom, right, we're using a property that I'll explain here. And again, you're expected to know this, called the difference of squares. Okay, that gives you this rule here. All right, please make sure you know this because this will come up and it is a common rule that you're expected to know. So what happens is when you have the two things multiplying, 5 plus root 3, 5 minus root 3, you do 5 squared, and then you do root 3 squared, and that's just 3. Okay. When you tidy everything else up, you have 40 minus 6, that's 34. Then you have minus 8 root 3, okay, and plus 5 root 12. The root 12, all right, is the same as 2 root 3 because it's root of 4 times 3, root 4 times root 3, 2 root 3, just to prove the point. All right. So the 5 root 12 effectively is 5 times 2 root 3. That's where we get the 10 root 3 from. Okay. So that's where that number there came from. Okay, tidying it all up now. Effectively, you've got 10 root 3 minus 8 root 3, 2 root 3. So 34 plus 2 root 3 over 22. Everything can be divided by 2. And you're left with the answer 17 plus root 3 over 11. All right. Hopefully that made sense. Okay, not far to go. The diagram shows graph of x squared plus y squared equals 30.25. This is the equation of a circle, which they've done for you, so you don't need to worry about that. And then they're saying, use a graph to find estimates for the solutions of the simultaneous equations as follows. One is obviously your circle. The other, again, into the y equals mx plus c format, right? Rearrange the y minus 2x equals 1 into y equals 2x plus 1, all right? So it goes through 1 as your y-intercept, that's there, and it has a gradient of 2. So go across 1 and up 2 and plot your next point. Do the same thing again, plot it up there, or go backwards 1, etc. Just 2 or 3 points and do a straight line through, okay? Again, in the real thing, sharp pencil, okay? Very important, otherwise it's not clear to the examiner what you've done. And what I've done, and I'm reading it off the graph, there's this point here and that point there, okay? I think that's roughly 2.1, so about the minimum there. Sorry, the value in the middle there, and about the middle there. Okay, if you can see, just to demonstrate that. It's not quite exactly 2 and 5, and each of those little squares represents 0.2, so therefore in the middle must be 0.1. So that's where I'm getting that value from. 2.1 and 5.1 is the first coordinate there. And on the negative side, again, I'm reading it off, something like that. And that one, sort of about the middle there, all right? So that again is minus 2.9 and minus 4.7. That's what they mean about finding solutions. Give your answer in coordinate form. All right, there we go. Done. All right. This next question is actually, starts off all right. The next bit is a little more tricky. Okay, when it says you've got these functions, so f of x means whatever you put into f of x, you square it, then times by 3, and then add 1. Okay, that's the order. Putting anything into g of x, you square it, and then whatever you've got, 4 divided by that. Okay, right, now, it says work out gf of 1. That means you first put 1 into f, get the result, and take the result and then put it into g. All right? So the first thing we're doing is working out f of 1. So 1 squared times 3 plus 1, 4. So f of 1 equals 4. We now take that and put it into g. G is, or g of 4 is, 4 divided by the input squared, i.e. 4 squared. That's just 1/4. All right, so I think that's self-evident where that came from. The next one is just a little bit more tricky. We want to find a function h, which is the same as doing fg of x and then finding the inverse. So it means the inverse of fg of x. All right, so let's find what fg is first. And as before, you put x into g first and then into f. Result of g of x we know is 4 over x squared. Put that into f, and let me show you what I've done. It's 3, and that's 4 over x squared all squared plus 1. That's what that thing actually means there. All right. So 4 over x squared all squared is the same as 16 over x to the power 4. Watch out for that. 3 times that plus 1. And that comes out to be 48 over x to the power 4 plus 3. Oops, hang on. I believe I've made a mistake there. Yes, I have. I need to redo that. Let's see. What have I done? Right. Let's try this. That should have remained as a 1. I'm sorry I didn't spot this earlier. My only excuse has been a long paper. It's taken a while. Right, that's corrected that stupid little mistake there. Right. Okay, so we now know, right, what the actual function is, 48 over x to the power 4 plus 1. So let y equal that function, and we want to find the inverse, all right? So rearrange to make x subject of the formula. All right. Now, in school, some teachers will say, well, look, write x and y the other way around. So you could start with x equals 48 over y to the power 4 plus 1, and then rearrange to get get y on its own. All right. So this is the alternative. You can pick which way you prefer to do that. All right. Okay, so rearranging this one, we've got y minus 1 equals 48 over x to the power 4. Now, what I've done here is, look, you've got this. Y minus 1 is a complete kind of item, if you like, 2 terms together. And you've got the x to the power 4. We can literally just swap them. If you have a equals b over c, we can rearrange to make it c equals b over a. All right? So that transition, that's exactly what I've done. Put x to the power 4, multiplied it across there, and moved the whole of the brackets underneath the 48. So x to the power 4 is 48 over y minus 1. And because it's x to the power 4, you want the 4th root. All right? This thing here. Okay? It's not usual to see that in GCSE papers, but recently this sort of thing, strange roots and powers, are coming up more frequently. So watch out for these, all right? And so your final answer, just to reiterate, because of my earlier mistake, it's the fourth root of 48 over x minus 1. You swap the y and the x at the end, all right, whichever one you start with, and you want the formula in terms of x, all right. I hope that's made enough sense. Anybody confused by my mistake there, please get in touch and I will redo it if I need to. Finally, last question. Find the coordinates of the turning point on the curve with equation that, so it's a quadratic. It's a negative quadratic, watch out. So the shape is one of those upturned U, all right? And in order to find the turning point, we use completing the square, all right? Because when you put it in the completed square form, which is this, take any quadratic and you rearrange to put it in this form that I've just highlighted, all right? The number within the bracket will give you the x coordinate of the turning point, and the number outside, the plus minus, the q, will give you the y value, all right? That will be the turning point. That is always true. Really important. See, this is a minus p, so x minus p squared, right? You have to reverse the sign. I better write that in capitals. Reverse the sign when you actually want the coordinates. So minus p becomes plus p, but the q remains the same, all right? Same sign. But for p, you must reverse the sign. I better write that carefully. All right. So how are we going to complete the square? All right, that's another video that I will be doing in the near future. So more detail on that if you need it in another video. All right, first thing, I'm going to divide everything by minus 3. All right, and so I'm factorizing out the minus 3. So with the minus 3 there, which leaves me with x squared minus 6x. Remember, if I'm dividing 18x by minus 3, then that's going to be minus 6x, okay? And 9 divided by minus 3 is minus 3 again, okay? The procedure for completing the square is look at the middle term there, all right? And halve it, okay? So you get minus 6 becomes minus 3. So x minus 3 squared, all right? Look at the values I've got on the right-hand side there. And I have to take away, right? Subtract whatever I had inside the brackets, the minus 3, square it, which is 9, plus 9, and I have to subtract. This thing is always subtracted, all right? And we had the minus 3 from the original. And remember, the minus 3 is on the plus, on the outside of the brackets there at the same time. Tidy that all up. You've got minus 12 on the inside there. And now we multiply the minus 3 back in. So look what you've got. Minus 3 times x minus 3 all squared. All right, so the brackets are all squared. And we had a minus 12 minus 3 times minus 12. You get plus 36. Now, watch out. Remember, it was x minus 3, okay, there. So this is plus 3, all right, not minus 3. And the 36 stays as it is. And that is that done, all right. That is actually a long paper. There is a lot of new things in these GCSEs since 2021, even what would have been 2020. and they started changing as a little bit more detailed working. And as I said, it's a much longer paper than I originally expected. I apologize again for a couple of small mistakes, like little errors, but hopefully I've managed to explain those to you. If there are any topics in there that you want another extra video on, or like, for example, completing the square or factorizing quadratics, frequency charts, etc., please do drop it in the comments, all right? And I'll be happy to try and help. And if you found it useful, then I'd be very grateful if you consider subscribing, leaving a useful comment, and maybe switching on the notifications. All right. So those of you who have watched, thank you very much. Hope it's been useful. And I hope you'll take a look at the next video. All right. Thank you very much.